Sketch the graph of y equals 2 times cos of x plus pi on 6 plus 1. Clearly label all axial intercepts, maximums and minimums with their coordinates. So for this graph, we're going to sketch it from negative 2 pi to pi, and that's going to contain a period and a half of this function. And we know that because the period of this cosine graph is equal to 2 pi divided by n, where n is the coefficient of x, and as the coefficient of x is 1, it's just 2 pi. So because the domain is 3 pi in length, 2 pi goes into that 1.5 times, so we're going to have 1.5 cycles of this graph. So before we go and find all of the key features, we're just going to get a feel for where this graph should be. So 2 cos of x without any translations at all would look something like this. So it would go from a height of y equals 2 down as low as y equals negative 2. And then, of course, the same thing would happen out in this direction. And now what's going to happen is this plus 1 will translate at 1 unit in the positive y direction. So every point on here will move up by 1 unit. And then the graph will also be translated pi on 6 units in the negative x direction. So it's going to be translated pi on 6 units in this direction. So I'll get rid of that, but keep that in mind as we sketch the next part of the graph. So our graph is going to look something like this, where this is going from negative 2 pi and cutting off at pi. And now the only reason I know to cut the graph off in those positions is because I've already gone through and found our endpoints, which you'll get to see done in a moment. So that's the shape of the graph, and now our job is to find the endpoint here at negative 2 pi and here at pi. Then we've also got to find the x-intercepts, which occur here, here, and here, and the y-intercept, which is here, as well as the maximum and the minimums of the graph. And hopefully you'll see that our algebra will confirm all of these points. In many cases, you'll need to do the algebra first so that you're aware of where the graph needs to start and end. So the first thing I'm going to go and find now by hand is the y-intercept of this graph, and that occurs when x is equal to 0 in our rule. So that means we will have y equals 2 times cos of 0 plus pi on 6, which is just pi on 6, plus 1. And now that will become y equals 2, and cos of pi on 6 is an exact value that you need to know, and it is root 3 over 2. So we'll have 2 times root 3 over 2 plus 1, and that is going to equal root 3 plus 1. So as a coordinate, this will be 0, 1 plus root 3, and that's the y-intercept. Next, we're going to find the endpoints. And the first one we're going to find is x is equal to minus 2 pi. So substituting x is minus 2 pi into the rule, we'll have y is equal to 2 times cos, and it's going to be minus 2 pi plus pi on 6, and then plus 1. And now y is equal to 2 times cos, and minus 2 pi plus pi on 6 is root 3 on 2 once again, plus 1. And now that is going to be just root 3 plus 1 because we have 2 and divided by 2 being multiplied together. So that is the coordinate here, which is going to be minus 2 pi, root 3 plus 1. And because I'd already found that, that's how I knew to stop the graph here. So if you didn't know that already, you'd have to find that to work out where you'd stop your graph. Next, we're going to find the endpoint for x is equal to pi. So we're going to have y equals 2 cos, and wherever there's an x, we're going to put in pi. So we're going to have pi plus pi on 6. And then we're still going to have plus 1. And this will leave y equals. And pi plus pi on 6 takes us into the third quadrant where cosine is negative. So we're going to have 2 times negative root 3 over 2 plus 1. And that value, when you simplify it down, will be 1 minus root 3. So that's this coordinate here, which is at x is pi and y is at 1 minus root 3. So again, that's how I knew to stop the graph at that point. Next, with our algebra, we're going to find the x-intercepts of this graph, and we know that they occur when y is equal to 0. So the equation we're going to be solving is 0 is equal to 2 times cos of x plus pi on 6 plus 1. And now there's another video that's gone through solving this. So I'm just going to give you the values that come out, and you can watch that video if you need to find them by hand. So we're going to have x is equal to minus 3 pi on 2, x is equal to minus 5 pi on 6, and the third one is going to be x is positive pi on 2. So they are the three x-intercepts that we have. So this one here is minus 3 pi on 2, 0. This here is the minus 5 pi on 6, 0. And this one here is pi on 2, 0. Now all that's left is to find our maximums and minimums. So to find the maximum, we can do that by finding the average or the midpoint between two of our x-intercepts. So this maximum sits halfway between minus 5 pi on 6 and pi on 2. So to find the average, we're going to take minus 5 pi on 6. We're going to add pi on 2, which I'm going to write as 3 pi on 6, and divide all of that by 2. So we have minus 5 pi on 6 plus 3 pi on 6, which is going to be minus 2 pi on 6. But minus 2 pi on 6 is just minus pi on 3. And then we divide that by 2, which gives us minus pi on 6. So the x value of this maximum is minus pi on 6, and the y value is going to be the plus 1, which is translated 1 unit up, and then we're going to add on the amplitude, which is the maximum displacement from that average y value. So it's going to be 1 plus 2 is 3. So that's the coordinates of the maximum. Now we know there's no other maximums, and that's because if we were to subtract a period, we would be subtracting 2 pi, and that would take us to minus 13 pi on 6, which is outside the domain. So there's no more maximums in that direction. And if you did the same thing and added on a period, you'd go well above pi, so there's no maximums in the positive direction either. Finally, we're going to find the minimums of this graph. And to do that, we're going to find the average of two x values that the minimum lies between. So for this minimum down here, we're going to find the average of minus 3 pi on 2 and minus 5 pi on 6. And just to make life a little bit easier, I'm going to make this minus 9 pi on 6. So that's just minus 3 pi on 2 with a common denominator of 6. So that I can add on negative 5 pi on 6 and take the average of those two by dividing by 2. So this is going to equal, and minus 9 pi on 6 minus another 5 pi on 6 is minus 14 pi on 6. And then if we divide that by 2, we find that it's equal to minus 7 pi on 6. So that means that the x-coordinate of this minimum is minus 7 pi on 6, and the y value is going to be the positive 1, which is the translation of 1 unit up, and then we're going to subtract the amplitude from that, so it's going to be 1 minus 2, which is negative 1. To find the next minimum, which occurs over here, we can simply add the period. And the period we found above was 2 pi, so we're just going to add 2 pi to the x value. And that will give us an x value of positive 5 pi on 6. And the y value is going to remain the same, so it's going to be negative 1. So that's the complete graph of y equals 2 cos x plus pi on 6 plus 1. And now quickly on this slide, we've got a computer to generate the same graph, and you can see that all the same key features are there labelled with their coordinates.